long, sorry. All right, so on page 7, sometimes you are not given the function. I told you it was long, I'm sorry. And you're given a table. So basically you have to use what you're given. I know. I have to do this again in 4th period, so feel bad for me. After this, you're done. So sometimes you're given a table that has equal subintervals, meaning all of your rectangles are the same width. And then sometimes you're given a table meaning you have, I'm just making this up, 4 rectangles, but each width is different, meaning one width might be 6, one width might be 2, one width might be 4. So you have all these crazy rectangles trying to find the area. Okay, so we need to use a table. We do not have a function. We can only speculate. So in the case of example 3, it tells you in the directions that you have equal subintervals, but when you're actually given a problem, it's not going to tell you. So this is how you find out. You look at your x values. To get from 1 to 3, you add 2. True? 3 to 5, same thing. 5 to 7, 7 to 9, 9 to 11, 11 to 13. So you can predict what the next series of x values would be if you were to extend the table, true or false. Okay, so that's how you determine if you have equal subintervals if it's not in the directions. So what I can say here is delta x is equal to 2. Does everyone see how we figured that out? Even if you didn't have this information. Delta x is equal to 2. Okay. So now what we have is f of 1 is 6, f of 3 is 9, f of 5 is 10, and so on. If you really had to, you could probably figure out what the function is, but you don't need to, because you have everything that they want you to have. So don't try to figure it out. The left sum. First of all, what they're saying is they want n is equal to 6, meaning how many rectangles do I have? So how many values should I have in my table? Exactly. 1, 2, 3, 4, 5, 6. Oh, 7. So I have enough. I have enough for my left endpoint. I have enough for my right endpoint. Okay. So my left sum is going to be L sub 6 is equal to, or excuse me, approximately equal to. My delta x is the same, so I can put the 2 out here. And now I can say f of 1 plus f of 3 plus f of 5 plus f of 7 plus f of 9 plus f of 11. The good news is they already did most of the work for you. You just need to write out how you are finding this area. Does everyone understand what I'm saying? Okay, so now we just say 2 times 6 plus 9 plus 10 plus 5 plus 4 plus 2. So this is what, 15, 25, 36. So what is this? 72. Can I ask you if this is an over or under? You don't have enough information, right? Yeah. Okay, so that's it. That's all you can do. Easy? Okay, equal subintervals, fave. Okay, unequal, not so favorite. Okay, so here we go. Right sum is approximately. Can I put a 2 here? Yeah. Okay. Then I have, where am I going to start?
13.
Nice. F of 13 plus f of 11 plus f of 9, f of 7, f of 5, f of 3, f of 1? No. Thanks. 2 times. So this is 1 plus 2 plus 4 plus 5 plus 10 plus 9. So this is 3, 7, 12, 22. Is that 31? Yeah. This is 31 times 2 is, it's approximately 62. Okay, can we jump to the trapezoidal? And we'll do midpoint in just a second. How do I do trapezoidal? Yes. So you've got L sub 6 plus R sub 6 divided by 2, which is 72 plus 62 divided by 2. Drum roll. Approximately 67. Okay. So everybody's good on those. Easy, right? Okay. So, as I stated before, when you are doing any of these using a table, you have to use what you're given. You cannot predict what is out there. You could if you really had to, because these are equal subintervals. When you have equal subintervals, using the midpoint sum, you will double the width. This is only when you have equal subintervals. Only for equal subintervals. This is really important because when I do the second table, you can't do this. Okay, so we already determined equal subintervals, true? So, midpoint. Guys, this method is so hard. You ready? Does everybody have this? Everybody have this? Okay? This is what you do. This is a left endpoint, you cover. This is the midpoint, you cover. Oh my gosh. There's your midpoint. That's the first one. Then I'm going to pick my fingers up and I move. There's my next midpoint. I'm telling you it's hard. Okay? And then I pick these up and I move over. There's my third midpoint. That's all I can do. But because the pattern is the same, whatever it is, I can double the width. Meaning each one is going to be double the width. So instead of 2, it's going to be 4. But because the pattern will be the same, whatever it is, it's going to be a more accurate measurement than unequal subintervals. So this is what you do. M sub 6 is equal to, if you're doubling the width, what is delta x going to be?
4.
It will be 4. Does everyone understand where the 4 came from? Okay. Times, it's f of 3 plus f of 7. Sorry, I have to do it. I just can't see it. f of 11. Thank you. Okay, so this is equal to 4 times 9 plus 5 plus 2. So what is this approximately? 64? Okay, so these are all pretty close. Yes?
So since we're only using 3 values, would it be, how come it's still m sub 6?
Because you're doubling the width, so it's still representing 6 rectangles.
Okay.
Now, in the next one with the unequal, it's going to be half the number.
Okay.
Yeah.
All right.
Good call, though. Okay. So equal subintervals, guys, make sure you take a look at this. This is what people miss every single time. Unequal. Okay. So this is where you have to be really, really careful. First of all, in this problem, it tells you that the subintervals are equal, but if you are not given those directions, take a look. 0 to 5 is 5. 5 to 6, yeah, not 5. Not 5. I mean, the last time I looked, it's not. Okay, you cannot calculate, oh, this is, the midpoint is 2.5. Oh, the midpoint, no. You have what you have. You have no idea what the pattern is. Because then when I go to the next one, it's 9. So it's just some Joe Schmo making up numbers in a table. Just throwing them in there. You have no idea what's going on, so you have to use what you're given. So you still do the same thing. They want an approximation for the area under the curve from 0 to 17 of whatever this function is, 4 subintervals, meaning 4 rectangles. How many values do I have in the table?
5.
Okay, so it's still kind of the same. All right, but you are going to have to take the width times the height for each rectangle. So it's different. It's not going to be delta x on the outside. So L sub 4 is approximately, here's my left height, here's going to be my width going from the first point to the second point. So that means I'm just going to write it out. So this is 5 minus 0 times 4. So this is my width, this is my height. I just wrote W and H. Plus, here is my second height. What does that mean when you have -6 as a height? Where is it? Oh, it went below the x-axis. That's okay. It's totally fine. It just means that that rectangle flipped upside down. That's okay. All right, so that means now my second width is going to be 6 minus 5 times -6. So then what is my third width? Nice. 15 minus 6 times -10. Plus my last width for the left endpoint is going to be 17 minus 15 times 20. Okay, so this is 5 times 4, which is 20, plus -6, plus, is that -90? 40? So can someone tell me approximately what that area is?
-36.
Okay. Again, describe for me what this means to have an area of -36. The majority of the area of all those rectangles is going to be below the x-axis. Okay, we don't technically have a negative area, it's just a location. Okay, and we do have graphs that fall below, cubic graphs fall below the x-axis and so on. Questions? Okay, so if we're calculating the right, R sub 4 is approximately, you're going to start on the right-hand side. This is your very first height, but what's my width? Yeah, it's 17 minus 15. So it's going to be 17 minus 15 times 5 plus 15 minus 6 times what? 20. Nice. Plus 6 minus 5 times negative 10 plus 5 minus 0 times, okay, do me a favor, approximate area, please. What's your crazy answer? That's right. It's approximately 150. Okay, so what did I say about unequal subintervals? Anyone remember? It is going to be one of, I said it at the beginning, you probably don't remember. It is the crudest because we don't know what the pattern is. It's all over the place. Okay? However, because I had to calculate left and right, trapezoidal, still the same. I'm going to get to the midpoint in just a second. So we've got L sub 4 plus R sub 4 divided by 2, approximately. So it's nice and easy. It's what's 150 minus 36, enter, divided by 2. It's 57. Okay, why am I saying that this is the crudest? Look at your values. Negative 36, 150, 57. But look at the problem above. Aren't those values all closer together? Yeah, more accurate. Because the widths were all the same. Okay, let's do the last one. Midpoint. And again, I apologize. I told you this was long. My apologies. Okay, so here, we have a midpoint. The problem is we want to find the approximation of 4 rectangles. For midpoints, am I going to have 4 using this method? Yeah, and I cannot do anything about it. I don't know what the pattern is. I don't know what the function is. I cannot even extend this table. So, as I was talking before, Max and I, we can only use 2 rectangles. That's all we can use, and we're just going to do our best. Is it going to be the most accurate? Definitely not. Okay, so if I were to ask you if you were given the true area, if I were to say which is the least accurate, you're probably going to choose this midpoint for an unequal. So let's see what happens. So in this case, we're going to use M sub 2 is approximately, because this is all we're going to get. Now you're going to have to do the same thing. So remember I did this? So that means this is my height. My width goes from here to here. So it's going to be 6 minus 0 times negative 6. So that means a big portion of that area is below the x-axis, right? Okay, so then I pick up my fingers and I move over. Okay, this is my height. My width is 17 minus 6. That's a big rectangle, right? So this is plus 17 minus 6 times 20. Just to save time, because I know you guys are so wiped out, this is 184. Okay, I can only speculate. I have no idea, but when I look at this, negative 36, 150, 184, 57, this is so jacked up. First of all, I don't have enough rectangles, unequal subintervals. It's kind of all over the place. But that's okay. It's an approximation. Okay, questions. I am asking you to make sure you go back and look at unequal subintervals. It is really important that you understand how to do the calculation.